Welcome to the module on production logging. Today we will learn about types of production logging surveys, design of logging program, production logging tools, flowmeter and its types, temperature interpretation with examples, fluid capacitance, holdup, quartz pressure, log quality control, and job planning. Production logging encompasses logging techniques to measure dynamic and static wellbore and reservoir parameters including a flow measuring device. The objectives of production logging include monitoring reservoir performance, how much fluid is produced, where is the fluid coming from, what type of fluid is produced, where is the fluid going, diagnose completion problems, casing leaks, tubing leaks, packer leaks, pour cement bond, plug perforations, evaluate treatment effectiveness, squeeze cement jobs, bridge plugs, hydraulic fracturing, acid treatments, conformance treatments. Types of production logging surveys. A production logging survey depends on the type of the well, the type of the survey, the logging method. There are many types of production logs, depending on the objectives of the test. Stationary, flowing, build-up measurements, multi-passes method, passes up and or down, any combination of pressures, temperatures, densities, holdups, phase velocities. Design of logging program. Is the well flowing in a steady state? Wait until stabilization occurs. Change choke size. Multiple spinner passes to determine correct apparent velocity profile. 30, 60, 90, 120 up and down. Stationary measurements to confirm flowmeter, holdup or temperature, and pressure readings. Shut-in passes for build-up pressure readings. Determination of thief zones, cross-flow. In situ calibration of spinners/hold-up devices. Production logging tools. Sundex, telemetry, gamma ray, CCL, flowmeter, full bore spinner minus continuous spinner, temperature, capacitance, flowmeter, inline spinner, pressure, CCL, density, centralizers. Flowmeter. A flow meter measures flow rate in terms of fluid velocity. The rotation is linearly proportional to the flow velocity. The spinner rotates clockwise or counterclockwise depending on the fluid direction and the relative velocity of the fluid with respect to the tool. It is one of the most important tools in the string. During the processing, the RPS are converted into velocity and the velocity is converted into flow rate. Flow is measured using a flowmeter in the center of the hole. The flow doesn't have to be measured in front of the producer zone. The flow has to be measured in the top and bottom of the producer zone. In the calibration zones, types of flowmeters. Cage full bore flowmeter, CFB 3-arm, CFB 6-arm. Continuous flowmeter, CFS. Inline spinner flowmeter, ILS. Diverter basket flowmeter, DBT. Cage full bore, CFB, flowmeter, 3 and 6-arm. Full bore flow meter is self-centered at the middle of the well bore. The mechanical section is available in different sizes to cover the different casing size. There are standard standalone tools and as part of the short stack, CTF. It allows a large diameter impeller to pass through small diameter tubing. 3-arm CFB helps to support the weight of the tool in highly deviated wells acting as a centralizer. The flowmeter is closed while running in hole, opening automatically when it leaves the tubing to enter the casing. The 6-arm CFB flowmeter provide more protection to its impeller when used in wells with large ID, gas lift mandrels and in horizontal wells. Continuous flowmeter, CFS. The continuous flowmeter has a fixed OD and impeller diameter. Works in tubing and casing. Spinner is protected by the case wall. In very high fluid velocity wells, CFS could be a better tool to run than the CFB. Sensitive to problems of plugging with debris. If there are debris in the wellbore, CFS with 3 side windows in the impeller housings is recommended to allow debris to escape. Sizes: 1/3/8, 1/2, 1/11/6, 2/1/8, 3/1/8. Inline spinner flowmeter, ILS. Mainly used as an alternate spinner or it is the only spinner when used with CFB to measure inside the tubing. Three different sizes are available: 1/11/16, 2/1/8 or 3/1/8 OD. As it is not a bottom tool, there is influence to the flow due to tool body. If possible, according with the minimum idea, larger spinner than the diameter of the tool could be used. Diverter basket flowmeter, DBF. The tool utilizes a patented fabric diverter element to divert wellbore flow up through a modified inline spinner. Its main application is to measure very low flow rates. It is done by reducing the flow cross-sectional area, forcing all the fluid to pass through the spinner housing. In multi-phase wells, the tool minimizes the effects of fluid segregation. Temperature. Temperature is one of the most useful auxiliary measurements made in production logging. Combined with pressure, it helps compute the private parameters. In addition, it will detect very small fluid entries and their flow. Gas entries, for example, are characterized by a sharp reduction in temperature. It is the only tool in the string that sees behind casing, hence it will detect channeling. The temperature gauge is in direct contact with the fluids in the wellbore and respond to all the changes of the system, inside the wellbore and behind the casing. Temperature interpretation. The interpretation of temperature logs relies on patterns. The change in temperature with respect to the geothermal gradient has to be noted. Heating means a fluid is flowing from deeper to shallower. Cooling means a fluid is injecting from shallower to deeper. The temperature is much more sensitive to small flows than the flowmeters. Let us have a look on an example of temperature profile. Fluid identification tools, density tool. The fluid measures the average density of the fluid in the wellbore coming from the perforated intervals. The main objective is determining the distribution of different kind of fluids produced from the reservoir. Density tools are as follows: gradiometer, mercury-filled. Fluid density differential pressure sensor, FDD. Nuclear fluid density tool, FDR. Fluid capacitance, CWH. Its main application is to distinguish between water and hydrocarbons based on the disparity in the dielectric constant of them. Tool has non-linear response and it is very sensitive in the 0 to 40% water hold-up range. Above this, water becomes more dominant. For qualitative interpretation, it should be noted that a trend towards a higher frequency denotes hydrocarbon and a trend towards a lower frequency denotes water. The tool is essentially an annular variable capacitor with a central probe as one plate and the cage housing of the tool as the other plate. The well mixture flows between the plates. The average dielectric of the fluid mixture governs the rate of charging of the capacitor. Hold-up. It is the percentage of the cross-sectional area occupied for each phase present in the pipe. Single phase does not require a hold-up device. 2 phases require 1 hold-up device. 3 phases require 2 hold-up devices. The devices cannot measure same fluid property. Phases are at downhole conditions. Quartz pressure. The gauge measures the pressure during the PLT passes. The pressure measurement is a continuous profile of the pressure in the wellbore. The curve reflects changes in the borehole fluid composition, density. The major reason to measure the pressure is to be able to accurately predict the PVT properties of the fluids. It is possible to use the pressure as a density measurement. Derivative. Log quality control. Constant line speed in passes plus or minus 3 feet per minute, line tension quasi-constant drag, increase line tension with line speed in upward passes and decrease line tension in downward passes. Depth match among all passes, gamma ray and CCL. Log length, 30 feet above perforations and 30 feet below perforations. Stations 1 minute above and below perforations. Header fill-in, well diagram, tool diagram, log titles and job log. Parallel flowmeter passes. Symmetric flowmeter response at sump, 0 flow. 6 passes are usually not enough. Spinner calibration plots. Pressures within plus or minus 5 psi among passes at the same depth. Temperatures within plus or minus 0.1 degree Fahrenheit among passes. Fluid density within plus or minus 0.02 g/cc among passes. Capacitance within plus or minus 200 Hz among passes, up and down sometimes different. Job planning. Job program. Multiple rate sequence. Gradient re and POOH. Reference depth selection for well testing. Till string selection. Well diagram. Passes depth interval. Tubing and casing size, full bore spinner selection. Tubing and perf. Perf sump. Stationary readings depth and duration. Thank you for learning with us.